Hi children. Last class we have discussed up to osmosis from the solution chapter. So today we are going to discuss what is osmosis. Osmosis is the process in which solvent molecules move from a region to lower solute concentration to region of higher solute concentration through a semi-permeable membrane. Then we are going to discuss what is osmotic pressure. The pressure required to stop the flow of solvent is called osmotic pressure. It is given by the equation pi is equal to CRT, where C is the molar concentration, R is the constant, and T is the temperature. What is the purpose of semi-permeable membrane? It allows the semi-permeable membrane, that is SPM, which allows the flow of only solvent molecules and not the solute molecules. That is why it is known as semi-permeable membrane. So there are two laws for osmotic pressure. First one is Van Hoff-Boyle's law. The law states that the osmotic pressure of solution, which is directly proportional to molar concentration. That's why we written as pi directly proportional to C at a given temperature. Then next law is Van Hoff-Charles law. This law states that osmotic pressure of solution at given concentration proportional to the absolute temperature. So pi is proportional to C and pi is also proportional to T. So we can conclude that by combining the two equations, we can, this is first equation, this is second equation, then we combining the pi is directly proportional to Ct, then we have to remove this proportionality by introducing a constant, that is R is here, it is a real gas constant, we get pi is equal to CRT. So we know that C is the concentration terms for what? In terms of molarity. First one, relative lowering vapor pressure depends upon the mole fraction, boiling and elevation of boiling point, depression in freezing point, which depends upon the molarity. And here it is depends upon the molarity. That's why we introducing the terms N by V, number of moles. We know that molarity is number of moles by volume. So we by replacing C by N, C is equal to N by V. So we get the equation is pi is equal to nRT by V. So rearranging this equation, so we get the pi V is equal to nRT here. Next, we are going to discuss the determination of molar mass. We know that according to Van Hoff equation, we get pi V is equal to nRT. We know that N is for the number of moles of solute. We know that how to find given mass by molar mass of solute W. B is always representing the solute particles. So by putting this in equation, we get pi V is equal to W by RT divided by MB. Then we rearranging the equation, MB goes to this side, LHS side, and the pi V comes to the denominator side. We get the final equation is as MB is equal to WB RT by pi V. So this method is very accurate, especially for large molecules like polymers. So the using osmotic pressure, molar mass can be determined by using this equation. So then that is here it's saying it is very accurate for finding out the large molecules like polymers. So next we are going to discuss what abnormal molar mass. So sometimes the molar mass obtained from this method, which is not correct, this is called abnormal molar mass, and it is occurs due to the association or dissociation of solute particle. So we know that colligative properties depends upon the number of particles. That's why there is a certain error occurs in molar mass, that is known as abnormal molar mass due to the associative and dissociative of solute particles in a solvent. So abnormal molar mass due to association. In association, molecules combine to form larger molecules, which decreases the number of particles in the solution. As a result, the colligative properties decrease and the calculated molar mass become higher than the actual value. So, for example, it is dimerization of acetic acid in benzene. Just go through the next one, the dimerization of benzoic acid in benzene. Next one, we are going to discuss the dissociation. In dissociation, molecules split into smaller particles or ions, increasing the number of particles. The increasing colligative properties and calculated molar mass becomes lower and accelerated. So in dissociation, it decreases the colligative property. In association, it decreases the colligative properties. In dissociation, it increases the colligative properties. So next we are going to introduce Born-Haber factor. To correct these abnormal molar mass, we introduce a factor called Born-Haber factor denoted by I, which is given by what? It is the equation I is equal to observed colligative property by calculated colligative properties. I is equal to normal molar mass by observed molar mass, or I is equal to number of particles after dissociation or association, or divided by number of particles before dissociation or association. This is one of the important equations we used here. Most of the numericals. Then modified equation of colligative properties. If one-half factor I is included, the equation for colligative properties can be modified. So delta TB, you know that KBM. So introducing a one-half factor here, that's why the equation becomes delta TB is equal to IKBM, delta TF is equal to IKF. Then pi is equal to ICRT, and P naught A minus PA divided by P naught A is equal to IKB. Last topic, it is what we have mixed here. The type of solutions. Okay, so there are different types of solution: isotonic, hypertonic, and a hypotonic solution. So if two solutions have the same osmotic pressure, then it is known as isotonic. If there is no change occurs in cell. If a solution has higher osmotic pressure, then it is called hypertonic, and which causes the cells to shrink. If has lower osmotic pressure, it is called as hypotonic and causes cell to swell. So it is caused by what? It is a normal cell. It is caused by isotonic. It is caused by hypertonic shrinking of cell, and swelling or happening due to the hypotonic solution. Then there is certain example has given 0.9 solution isotonic with respect to human blood. That's why we are intravenous injection. It is used for intravenous injection. Then there is certain examples for hypertonic, and just go through it. Then we just state the term edema, retention of water in intercellular space of people taking salt food due to the osmosis. So it is edema means it is retention of water. The people who are consuming more salty food, so there is water decrease in their body. That is known as edema here. So just go through this, and then we are going to discuss reverse osmosis. If a pressure greater than the osmotic pressure is applied on the solution, the direction of solvent flow is reversed. This process is known as reverse osmosis and used in purification of water. So there is a diagram has given. Just go through it. There is certain applications for osmosis: capillary rise of liquid, absorption of water from soil to plants, preservation of meat, etc. So we have completed this chapter. So if you have any doubts, we can discuss in coming classes. So thank you.